Hello and welcome back to another episode of Math with So. Today we are going to be doing some properties of parallelograms. Okay, so to refresh in case you haven't done anything with parallelograms, some things that are true with parallelograms. I'm going to use number 2 as an example because it's a little bit bigger. The opposite sides are congruent. So those two sides, D and E and C and F, are congruent. And the other sides over here are congruent as well. C to D and E to F. Those two sides are congruent. The other things that are true is that if this is 70, this angle across from it will also be 70. All right? Not only that, but angle F, so we'll put a box here, and angle D will also be equal to each other. Okay? The last but certainly not least is that angles that are on the same side, that 70 plus angle D have to equal 180. And the reason why is because those are considered, what do they call it? They call it not corresponding, same side interior angles of a parallel thing. So, and most obviously, opposite sides are parallel. That is like the definition of a parallelogram, which I did it down here because I was running out of room for number 2. So if these two things have to add to 180, 70 plus angle D would have to equal 180. If we subtract the 70 over, that means that angle D is going to equal 110 degrees. All right? No big deal there. Let's do another one. Let's do number 4. What do we learn about opposite angles? Opposite angles are equal. So angle L will equal 90. Ooh, that's a very ugly 98, but it is still a 98 degrees. All right, let's do number 6. We're rolling right along here. Number 6, we got opposite sides. Opposite sides of a parallelogram are equal. So this is going to equal 12.6. They don't give us a unit, so it's just 12.6. Okay, so some new things that we might have to recognize here. We have R to T is 19.8. From here to here is 19.8, which I'm going to put a circle around it. Find R to P. Well, what do you think T to P also will equal that we didn't talk about with the previous, number 2 things, properties of parallelograms? I think that whenever we have these two diagonals, that they end up breaking each other in half, and I think that this is also going to equal 19.8. Okay? But it doesn't ask for T to P. It asks for R all the way to P. So that is going to be 19.8 times 2, or 19.8 plus 19.8. I like the times 2, but I figured we could add 19.8, multiply by 2, or add it together with itself, and you get R to P is equal to 39.6. Okay? Here we go. 8 looks like a different problem as well. We got 60 over here, and that means that 60 is going to be over here. Okay. What else can we do? Well, see how we have a triangle here with y to x to v? That triangle will have to equal 180 degrees. So I'm going to find this dot right here. Because it's a triangle, it will have to add to 180. So if I take 180 and I subtract the 62 and I subtract, nope, it's not a 62. If I subtract the 60 and I subtract the 52, whatever's remaining will be that angle right there. All right. And then they have this thing in parallelograms, if you might remember it, called alternate interior angles. So if I have a dot here, the dot here would be equal to each other. You can kind of see that this dot and this dot, where the question mark, are doing the same thing. So this angle right here would also equal 68, which is what we're asked to find. So we technically have our answer, but to reiterate, this 52 would end up being right here as 52 as well. All right? No problem, no problem. We might want to do another one of those. Let's see, we got 55 here. 55 would go on the opposite side. We got two sides of a triangle. We need to find the third by subtracting from 180. And whatever we get here will also equal the dot for our question mark. So 180 minus 55 minus 62 is 63. If it's 63 right here, it is going to be 63 right there on the inside as well. So that would be the angle CDB. All right. Equations. You know how geometry always does it. You learn the basic stuff, and then they're like, oh, well, now that you can do it, you need to be able to solve equations. So here, do these two equal each other? And if the answer is no, normally with geometry, if they don't equal each other, they add to equal 180 degrees, and that is no different here. If you don't have them across from each other, z and x would equal each other, but if they don't, they add to 180. So we got 11x minus 10, and the 80 would have to add to 180 degrees. We got to combine like terms. 11x, negative 10, and positive 80 makes 70 equals 180 degrees. Subtract 70 over, we get 11x. When we subtract 70 from 180, you get 110, which means x equals 10. When we divide by 11, of course. Okay? So, 15. They're not an angle. If it's not an angle, they're either equal to each other or they might have to be like doubled to equal each other. So in this case, 7 and x plus 1, they equal each other. They're opposite sides. Subtract 1, you get x equals 7, or 6 is equal to x, or x is equal to 6. All right, this one we might have to double. Let's see. U to h is 19. F to h, which is the whole way across, is 5x minus 7. What do we have to do to the shorter part to get to the longer part? You either can double it or you can add it together with itself. So I'm going to represent it as 2 times the shorter part. The shorter part is 19. And the whole way from f all the way to h was the 5x minus 7. So I did 2 times the shorter part to equal the longer part. I actually multiply 19 times 2 to get 38, and that equals 5x minus 7. Add 7 to both sides. If we add 7 to 38, we're out of room, but we end up with 45 when we add 7 to 38 is equal to 5x, and when you divide 45 by 5, you get 9. Okay? Let's see what else we got here. I'm going to do one more. I'm going to do this problem right here. The only things that you got to do on these is also plug it in. We've been plugging in things for a while, so I want to do a slightly harder problem, which is 18. K to u is 3x plus 3. U to m is 4x minus 4. Is this a case where we have to double either shorter side to equal the whole way across? And the answer to that is no, because you have short part and another short part. Those two short parts are like half of the entire thing, so they're going to be equal to each other, not have to be multiplied by 2 or anything else. So I'm going to personally subtract the 3x over because I know that I can subtract 4 minus 3 to make 1x. This 3 drops down. That minus 4 drops down. We have to add 4 to both sides. And we get 7 is equal to 1x, which of course means x is equal to 7. Okay? That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.